Hello, is there anyone? Anyone there?
Okay, hi everyone. How are you doing, guys? Am I audible?
Yes.
Yes.
Yes,
Okay.
you are audible.
Okay. Okay. Hello, everyone. My name is Shank, and I will be your instructor for this course of ACI and Sg-1. Welcome everyone to the Network Journey course. So, about myself, I am CCCIE certified and CCIE inside routing switching service provider and data center, and having overall experience of 13-14 years in the networking field. Okay, I've worked on all the technologies related to your ENT enterprise data centers, service providers like your MPLS, VXLANs, ACI, SD-WAN, all that stuff. Okay, and I work in almost all roles like solution architect and cloud consultant and pre-sales engineer and all. So that's all about me. So those guys who are newly joined today, I want 5, 6 people to provide your intro. Okay, what is your expectation from this course? Okay, what is your current experience and where are you from? Okay, so these 4-5 questions you can provide me with your intro and then we can carry forward this. Yes, go ahead. So you can unmute your mic and you can provide your intro.
Hi, Shank. Myself, Padma Kumar.
Hi.
I want to learn ACI because I have ACI in production. I am a network engineer. I have like 8 years of experience in networking. So ACI is a new technology for me. That's why I want to learn.
Okay, great. Welcome. Next.
Hi, this is Ben from the US.
Mhm.
I've also been a network engineer for the past 9 to 10 years. And at the enterprise level, I have been using Nexus switches, almost all the flavors, and seeing that ACI is the new way to go. So I would really want to know about ACI, and I want to make sure to know it before it takes over the Nexus suit.
Okay, welcome, Ben.
Thanks.
Next.
Hello, hi everyone. Kalpesh from Mumbai, and I want to improve my skills with ACI, so I will join that class.
Okay, welcome, Kalpesh.
Okay, thank you.
Hi everyone. My name is Takunda Shab. I'm from Harare, Zimbabwe. I have 8 years of experience from an ISP environment. I'm here to learn more about ACI because it's a new trending technology that is making its way into the industry.
You're welcome.
Hi, this is Deepak Singhal. I'm from India. I have 15 plus years of experience as a network architect. I have basic knowledge of ACI, and so I'm looking out for more experience into ACI and brush up my skills with Nexus and ACI. That's why.
So what is the basic knowledge you have?
I have like spine and leaf technology and APICs, Nexus 9300 switches and Nexus 9500 switches. How these all works with ISIS. These kind of basic knowledge I have.
What about L2 out, L3 out? These all things, you know?
Yes, not much, but yes, I'm having the basic concept of that.
Okay, great.
Thank you.
Okay, welcome.
Yeah, hi all. So this is Gaur. I have also like more than 8 years of experience in enterprise and data center. So I have worked in ACI like in 2019. and currently I'm working on Sg-1 also. So I want to brush up my knowledge, and I was an L2 engineer when I was working in ACI. I want to be an L3.
Okay, welcome, Gaur. I think you joined the demo previously as well, right?
Yeah, right.
Okay.
Yeah.
Okay.
Because in our project, when ACI came in our project only, it started. So it was started in 2018-19. So
Okay. Okay, guys.
but then
Anyone
they have
else wants
migrated
to?
to Arista, like ACI, like most of the spine leaf switches got rebooted and all. So due to bug and all, then after that we have migrated to Arista.
Okay, great. Okay. Anyone else want to provide the intro? Okay, guys. So we're gonna start. Just give me a second. Okay, guys. So welcome everyone. And this is a course where we're gonna discuss and implement two different technologies. One is ACI, another one is Sg-1. Okay, and we're gonna start with the ACI course from today onwards. Okay, this is basically not a demo class. This is gonna be a live class which is gonna happen every weekend at from the same time 6:30 p.m. IST to around 1.5 hours or 2 hours. Okay, and after we finish with the ACI batch, we're gonna do the Sg-1 on the same time. So what is the syllabus that we're gonna cover up? Okay, so I'm gonna just tell you the quick brief of that, and then we're gonna start with the topic of the day. Not actual, it's like the complete what we can say from the course starting. We're gonna start it up. Okay, so network journey, SDN, orchestration. So regarding the course detail, guys, you can take, you can get the details all like fee structure and all that stuff from the backend team. Okay, I'm gonna provide you the email ID in the chat or the WhatsApp number over which you can directly call it up. Okay, so frequently asked question we're gonna discuss this later today, in the last 10 minutes. Okay, although you will get all the details on this page. This is the page for our this class. Okay, so Cisco ACI and Sg-1, these are the two different technologies we are taking. Okay, so this is what we are starting it from today. Okay, the course name is DC-ACI. After DC-ACI, we're gonna, once it is finished, we're gonna start with the Cisco Sg-1 course. And the syllabus that we're gonna cover it up is as per the Cisco blueprint. Okay, so you can check it DC-ACI syllabus here as well as on the Cisco website as well. So these are some of the modules which is having both the theory part and the lab part. So module 1, 2, 3, okay, which is gonna be starting from the very basic, okay, and we're gonna go with that. Similarly, the syllabus you will have it for the Sg-1. The course is ENSDWI. So this is gonna be a complete syllabus for that theory and lab part. Okay, this is our lab topology for Sg-1. ACI I'm gonna show you as well. Okay, so you can read up the whole page to get the more insight. Although you will have any other question, we're gonna discuss it later on today itself. Okay, so now I'm gonna start with the course itself. The first two classes is gonna be free for the peoples who not enrolled to the course. After that, the class is gonna be logged and it is gonna be only for the enrolled students. Okay, regarding the lab for ACI, it is on the virtual platform. So all the things related to the control plane, like policy configuration and all that stuff you can do, but the data plane will not work. Okay, so end-to-end ping will not work, but all the policies, all the configuration, you will be able to do it. Okay, so this is what I need to tell you before starting the course as well. Okay, so with that said, let me now start with the topics.
Pardon, can you repeat again? What did you say?
What you missed? What part?
That you're talking about that control plane at access.
So lab is on the virtual platform. So virtual platform, your data plane will not work. Means end-to-end ping you cannot be able to do, but all the policies, configurations, all that stuff you will be able to do. Okay, it's like the only the verification part, which is verification also through the GUI you can do. Okay, but end-to-end ping will not work. That is it means.
Okay.
Yeah. Okay, guys, just give me a second. Let me open my pad.
So if end-to-end verification is not possible, then whatever we did the configuration, it is okay or not? How can we understand?
So how to build the complete policies and configuration that we can see via GUI part. Okay. Show commands, you can check it up, but end-to-end ping will not work. Okay, that is the limitation of virtual platform. That is what I want. I always say in all the batches before starting. So again, it's your choice whether to enroll it or not.
So before 1/2, we can ping whatever
Sorry?
the device. Before end-to-end, before 1/2, like P to P, we can ping.
No, you cannot ping any device. Okay, data plane is not simply worked.
Oh.
Okay, so now let me share the screen.
Will you be sharing with us the recorded video link later?
Yes, all the lectures which I am taking is going to be recorded and it will be present on the portal. You will get the portal access of Network Journey on the same website. You will have all the links and you can get it on that. So if you missed it, you can watch it. Okay. So let's start with the course. So the first thing is, what do you guys think? Okay, so this session is gonna be interaction. Okay, I'm gonna do a lot of interaction, guys. And in my course also, I'm gonna do a lot of interaction. So any point of time, if you have any question, you can ask me. Okay. And so before we starting, so let's understand why ACI. Can anyone tell me why there is a need of ACI?
To do automation and
hope you able-
orchestration inside data center networks.
I hope you're able to see my screen, right, guys? So I have written the ACI with the yellow font color.
No, we see your browser showing the network journey website, the
Okay.
home page.
Okay, just a second then. Let me check. Okay, now.
No.
No.
Still not able to see? Okay.
I think you're sharing the wrong screen.
No, just a second. Because multiple devices are there, so just give me a second.
Hi.
Okay, so now I hope you're able to see it.
Yes.
Okay, so to understand why we need the actually ACI, so tell me guys, what are the traditional network challenges you have in data center?
Automation, centralization of administrative part.
Centralization, what else? Automation, what else?
Resiliency.
So what do you understand by resiliency? Because a lot of people will
So,
not be able to understand that.
so basically we can have resilient setup. You can have multiple links, VPCs, and you can add drop nodes without any impact in the current environment. Also, you can have multiple leaf. So the resiliency in perspective of you can have your servers connected to 2 leaves, and if one leaf goes down, still your connectivity will be there. So that is one thing. And central administration, as someone said, port capacity is something you can go up to 400 gig now with latest Nexus.
But what is, I'm asking about the challenges.
Oh, okay.
Report generation.
Yeah, in traditional network, we don't have a centralized policy. In ACI, we have a centralized policy, like which is called Epic, where you can push all the configuration from the controller.
I'm asking about the challenges only. We're going to see what we can do with the ACI.
There is no application-centric management not available in the traditional one.
Which one?
Application-centric management, we cannot do it.
Application-centric. Okay, what else?
I think scalability is an issue in traditional networking.
I have point, but died out. GUI informant.
Curtis, just a second, guys. Curtis, this is already recording, and it is going live in YouTube, LinkedIn, everywhere. Okay, so you can watch it later as well. So no need to record it from your side.
No. I'm saying like in traditional network we are using CLI more, but whereas in DCN we can use GUI to push the policy easily, policy and configuration part easily on ACI.
So basically, it is in traditional. You will have CLI to every device, which is hard,
yes.
right?
Yes.
As so we scale. What else?
In short,
topology point of view.
Okay.
Anything related to topology point of view?
Means it is a graphical representation, right? Means GUI base.
In topology perspectives, there are three layers in legacy, but in ACI there is only two layers, spine and leaf.
So what is the problem with 3 layers?
You need for distribution you need different routers, and for LAN distribution we need core switches, and then we have access switches on that. Apart from that, here we can use leaf switches. Yes, go ahead, please.
So here also for different series we are having different devices.
But here we have 2 hierarchy only, right? Spine and leaf.
That is okay. So what is the benefit of 2 hierarchy as compared to 3 hierarchy?
Less devices to be controlled. As it came in my mind.
So here, if I tell you that in 2 hierarchy we are using more number of devices as compared to those 3, then
yes, we are using more. If we have large networks, we need to.
So one thing is we can say it related to the L2 and STP problem. okay,
Oh,
which
yes,
is there
yes,
in
yes.
legacy,
Yes.
okay,
Security
which
issue.
is logged
Yes.
links you are having. What else,
Yes.
guys?
VLAN.
It's a,
Yeah, in
Security issues.
ACI normal we can do VLAN. In ACI we have the concept of VXLAN, which you can extend the layer 2 over the layer 3 fabric.
So what is VXLAN is going to benefit?
As you know, like VLAN will support up to 4,000. Like
So
VLAN is a limitation.
VXLAN you can run in normal as well. You don't need to run ACI for running the VXLAN. I can
Yeah,
run VXLAN on Nexus devices, which are not running ACI.
so we can with the VXLAN we can like have the MPVGP concept as well, EBPN.
Do not tell me concepts. Tell me what is the issues you are having.
Yeah, VLAN, like the concept of VLAN is different in ACI, so it is easy to add a new network in ACI, and I think the internal communications are all very easy. There is no like much to troubleshoot. Issues are coming in ACI.
That is actually not 100% true. If I tell you about the bugs and all that stuff in ACI, then it is not like problem can happen in any network, right? So troubleshooting is needed if problem comes, right?
Yeah.
But key difference is in normal VXLAN and ACI VXLAN. ACI VXLAN you can combine with policies. So you can use VXLAN as per applications and as per EPGs. So I think that's the high difference. I'm not sure in low level, but something related to this.
One more question. More, we can use more virtualization rather than legacy. Just a thought. Virtualization
So guys,
is more. Yeah.
Right now there is we are not doing any comparison. We are asking about the challenges. So again, if you have, so one challenge is no zero touch provisioning. I hope you guys know what is zero touch provisioning. If not, we're gonna discuss that. Then that is a black. Your traditional network is blacklist security model. What does it mean? Said everything is permitted. If you are not using security devices like firewall and all that stuff, so you can move your data freely between your devices, right? Like between your routers and switches. Okay. Then
Performance degradation.
Sorry.
Performance degradation.
And how
performance
that is how what are the what are the performance issues you get?
Here the performance is very close in the traditional network.
Very slow.
Yeah.
If I put a 400 gig,
compared to
then
ACI.
no. So how? Feel like again you are doing the like comparison between them, but again, what how at what parameter you are talking about? If you're talking about at the bandwidth level, so again, your normal networks also supports 400 gig links. Okay, so troubleshooting,
monitoring and maintenance.
Yes, so troubleshooting, we can say it is complex, monitoring and maintenance. So we need a different tool, right, for monitoring and maintenance and all that stuff. Okay, so these are some of the challenges, right? So how your ACI is gonna solve it? So guys, here we are having ACI is a part of your SDN umbrella. Okay, SDN means software defined networking. So if we talk about software defined networking, every software defined networking element, any solution which is software defined, okay, is gonna be having one thing which is known as controller, which is a centralized controller. Okay, we're gonna talk about this centralized controller in much more detail later on. So here the centralized controller is Epic. This is gonna do all the centralization. Okay, it is gonna do your trouble monitoring, maintenance. You can do troubleshooting as well from here. You can do upgrade directly from here. Okay, of your devices, all of your leaves, spines, and all that stuff, whatever is there. Okay, then so this is one thing. After that, you will have, this is gonna be automation. So automation is again, you can do the API calls to do the all the automation, all the languages are supported, right? And it's gonna do your all the automation part. Okay, so that is there. Application centric. So you can build your network model based on your application. Okay, previous models are based on the network layers, and your applications need to suffer due to that. But here, as per your application requirement, you can make a model. Okay, so this is what is known as application centric. Okay, you can define based on your application tiers. So I hope there are any people who is from the development team here. I don't think so, right? All of we are networking people. So they are like, you will have a database team different, you will have a middleware team, you will have the front end team, back end team, which is related to application. So these are different application tiers, so we can go at the application level. And here the one more thing is you can monitor your network as well as your application as well directly from your centralized environment. So if your any application server got down, you can get the thing out of it. Okay, so this is what you can get the alert and you can get the health score of that. Okay, so there is a concept of health score which is going to tell you about your devices, about your application, all that stuff. Okay, then scalability is very easy here. All leaves are connected to all the spines. We're going to talk about the topology in next 10 minutes. So scalability is not an issue here. We can add as many as we want. Okay, although there is a hard limit, but again, that is a very huge limit. So still no issues with the limit. Okay, related to scalability. Then you will have a centralized management. You can have the GUI access, API access, CLI access, whatever access you need. You can do the centralized configuration through your Epic controller, okay, via any of this method. Then your ACI devices are connected to each other with the L3 links, so there is no L2, okay, no L2, no STP. Okay, your ACI devices are supports ZTP, which is known as zero touch provisioning. What it means is you can do the whole configuration before your device is shipped to your location. And once it is plugged into the network, it will take first of all IP from the DHCP, and then as soon as it gets the IP, it will try to communicate with the controller, and it will get the configuration from the controller. Okay, so you don't need to send the L2 or L3 engineer at the location to do the configuration. All will be from your centralized data center or centralized location. You can do it. Okay, so that stands for ZTP. Then here in ACI, you will have a whitelist model. So as compared to blacklist, you will have a whitelist model. So what is going to happen is no device or no, right now I can say VLAN can talk to any other VLAN. Okay, there is a concept of EPG here, but we're going to discuss it later on. So no device can talk to each other. Okay, unless until you allow it. So all the communication is by default blocked. Okay, which is in the traditional SB permitted. Okay, your troubleshooting is not as complex as you are having in your traditional network. Monitoring and maintenance, I already told you, from the same pane of glass, from your same device, Epic controller, you can do the complete monitoring. Okay, it reduces. So again, what are the other benefits? You will have end-to-end health score. Okay, so you can see how your devices are performing or how your application is performing. So it is both for your devices and for your application level as well. Okay, so if any changes you're gonna do in the application, it's gonna automatically change your network. Okay, it reduces your errors, your overheads. Okay, you will have increased productivity, accuracy. You can configure the policies. Okay, this is the most important thing. Okay, you can create your templates and policies, and those you can implement to multiple devices within seconds. Okay, so template is known as the same type of configuration which you want to put it on different devices. Policies dictates your behavior of your control plane traffic and data plane traffic. Okay, you can automate these policies as well through the automation. You can do all these stuff. Okay, so
Hello.
yeah,
Can you just repeat again policies and template means?
so template is gonna be a set of configuration which you're gonna be putting on your devices. Okay, so it can be a single set or multiple set of configuration which you're gonna put on the devices, and policies is gonna dictate your traffic flow, how your traffic flow will go, or how you want to uh, means what is your control plane traffic and how it's gonna go, and what is how your data plane traffic is gonna go. Okay, so this is what it's gonna do.
Okay.
Okay.
Cisco ACI means it is a device, right?
So it is not a device, it is actually, you can say, like a technology or terminology. Okay. Then,
Okay, and it is a centralized placed in as a cloud base, right?
so it can be cloud based, it can be on premises. Okay. So it suppose both. So basically it comes into the SDN. Those who don't know, SDN umbrella
Premises means
at your location, not in the cloud, your own data center.
yeah, but it is not the device, right?
Sorry.
It is not a device, right?
So it runs on a set of devices. Okay, it will not run on any of the device. The fabric that you're gonna make it with the ACI, the topology that you're gonna make it, it's gonna be on a particular set of devices. Okay, there are particular models which is gonna only support that.
Shank, I don't know if I get you right. You said the devices don't talk to each other directly, so they speak to the controller. Is that?
Sorry, didn't got you.
So yeah, over there, yes. The last you said the devices don't talk to each other. They speak through the controller. Is that?
So again, I'm gonna tell you how the devices are connected. Just give me 5 minutes. Okay, so in SDN umbrella, we are having your data centers, we are having LAN side, WAN side. Okay, so if we talk about Cisco solutions, okay, so ACI is a solution for SDN for your data center. For WAN, it is SD-WAN, and for LAN, it is SD-access. Okay, then everyone is having a controller. So ACI is having the controller known as Epic. For WAN, the controller is gonna be 3 controllers: vManage, vBond, and vSmart. And for SD-access, you will have a DNAC as a controller. Okay. So now, as a part of this one, we are talking about here. Then after finish, we're gonna talk about the WAN thing. Okay. So anyone having any other question before we move on further till this point? Okay. So after this, guys, now let's talk about the topology. So you will have a particular type of topology that is going to be made in the ACI. So we're gonna start with the basics, then we're gonna go later on in our courses with the advanced topologies like multi-pod, multi-sites. Okay. So first of all, let's understand the basic fabric topology. So it's gonna work on a topology fabric which is previously present, which is known as cross fabric. So cross fabric is basically a two-tier architecture where you are having two layers. Okay. So basically cross is the name of the scientist who developed this one for the PSTN phone systems. Later on, these architecture come into the data network. So what is going to be happen here is in this, you will have two different layers. Instead of three-tier model, you will have two-tier models. So the first layer is known as spine layer. Okay, which is going to be representing the backbone. Okay, if we compare it with the three-tier, then you can assume it like core and aggregation. Okay, this layer. The second layer, which is going to be there, is your leaf layer, which is access layer. Okay, so your end devices is going to be connected to this, and not only the end devices, your all other traditional devices is gonna be connected to the access layer. Okay, so that's for this point of time, you need to make sure that everything is connected to access. Now we have some advanced designs, okay, where you can connect some things with the spine as well, but later on we're gonna discuss about that. So this is gonna be your spine devices. These are gonna be your leaf. So I'm representing it with the L1, L2, L3, L4. Okay. Now there, if you want to discuss about this connection, so there is a conditions for this connections. Okay. So the first condition is your spine devices will not connect to each other. Okay. So they're gonna be connect to leaves only. And every spine is gonna be connected to every leaf. Okay. So this is the connection, for example, from my first spine. And this is going to be the connection from my second spine. Okay, so the first condition is your spine is not going to connect to each other. Your spine, second condition is spine is going to connect to every leaf. Okay, the third condition is your leaf is not going to connect to each other. Okay, if you try to connect them, there is a one protocol which is automatically runs in the ACI, which is known as Miscabling Protocol. It's going to kick in and it's going to disable your port. Okay, so better not to connect it. Then you guys will thinking of where we are having the controllers. Okay, so your controllers is going to be connected with your leaves. Okay, and minimum 3 controllers Cisco recommend for redundancy, and there is a concept of data shedding which I'm going to discuss later on. Okay, so minimum 3 controllers are needed to run the AC environment properly. Okay, now how they're going to connect it? So it depends on the network card which is present on your, these controllers are basically Cisco C series servers. Okay, which is having a EPIC or ACI software installed over them. So they come with the VIC card, depends on the model. Again, we're going to talk about the different models and different VIC cards. For example, this controller is having two port card. Okay, so you can connect to any two leaves. Okay, there is no compulsion. You can connect wherever you want. Okay, which with any leaf. Then this is, for example, you have 1, 2, 3. Then the second one I can connect it like this. Okay, third one I can connect it like this. So it depends on your choice. Better to connect it with different leaves to provide the redundancy, but there is no as such hard requirement to connect it. Okay, so some controllers are having 2 ports, some controllers are having 4 ports. The controllers which are having 4 ports, they were going to be connected in the ether channel in the bundling. Okay. Okay, guys. So now after this, can you tell me the advantage of this design and disadvantage of this design? Any two advantage and any two disadvantage?
Where's redundancy and central management?
Sorry?
A lot of we're seeing redundancy and then ease of for centralized management of the devices.
Okay. What else?
If we want to add any new switch, new leaf switch, it will not make a disruption in the current configuration or current network. So
yeah,
in traditional,
that is actually the most important advantage, okay, which is gonna increase the scalability on the fly.
correct, correct.
Mm-hmm.
Just
What
will add
else?
in the controller like the node ID, and it will automatically push into the fabric.
What else? Each leaf is one hop away with another leaf, so you will have a predictable latency. Okay, all the devices are exactly at the same hop away, so predictable latency. Okay, you will have. Then the links that are these, all the links, okay, which is present in between, like these ones, yellow ones, and red ones. Okay, all these links are L3 links.
I asked my question.
Just a second. So these L3 links means there is no L2 link. If there is no L2 link, that means there is no STP. Okay. And if there is no STP, no block links. So this is what they are serving as a equal cost multi-pathing. Okay. Yes, tell me. Yes, tell me.
Which device is working in layer access? Do you kind of some devices according to switches or routers? Thanks to explanation, this is right.
Yes, I'm gonna discuss that. Give me 5 minutes.
Okay.
Could you also stress on the disadvantage when it comes into the having a hub away from the spine, so that going to create some sort of latency? Could you stress on that?
So this is an advantage, not a disadvantage.
Yeah, most disadvantage is like I can say, like if one of the spine switch like got rebooted, then all of the leaf switches connected to that spine, it will have an impact connected to the storage. So
no,
we can say
no,
like
no, this is not a disadvantage, Gaur. This is not a disadvantage because your other spine is
will be
having
active.
the,
Yeah, means we are running in a redundancy loss of situation. That's what.
yeah, so basically your bandwidth is gonna be half. Okay, that is what is gonna happen, but none of the leaf is gonna impact based on that, apart from the bandwidth. Okay, so any other disadvantage, guys? What you think of by seeing this topology?
A lot of cabling.
Yes, so it increases your cabling cost. Okay, this is the most important disadvantage.
Also, number of ports on the leaf, can be limited.
It increases your switch counts. Okay, it increases your switch counts as well.
Yeah, one
so
more.
Number of ports is not a limitation because again, when you are full with the ports, you can add another leaf. Okay.
It will be it will be more expensive, right?
Expensive, yeah.
So it depends. Right now, we not go in that scenario whether it is expensive or not, because that is a different part of story. Okay, so now let's discuss about the devices. Okay, so guys, all these devices. So APIC, I told you this APIC is gonna be Cisco C series servers, which is having the APIC software pre-installed over them. Okay, so that is they're gonna get it shipped via Cisco directly. What about the spine layer and leaf layer? Okay, so for spine layer and leaf layer, you will have the Nexus series. Okay, so Nexus series. And in Nexus, so again, guys, these is going to be Nexus switches. And in Nexus switches, you are having a lot of series. So those series, out of those series, there are two different series, which is 9500 and 9300. So these are the two series which is gonna be support your ACI environment. Okay, because now what is gonna happen is there are two OS. One is NX OS, which runs on Nexus devices, and for running the ACI on the devices, you will have ACI OS. Okay, which is different from your Nexus OS. So only these two series support your both OS. Okay, apart from that, whatever the other series you are having, for example, 92, 77, 7000, 6000, 56, 55. Okay, and there are a lot of series in 3000, 31, 32, 33, right? 4000, then 26, 25, 2000, 1000V, whatever is there. All these devices will not support ACI. Okay, it will not have the support of ACI OS. So these are the only two series. Okay, there are multiple devices are present in that, which we're going to talk about. So 9500 series is used for your spine layer. Okay, but there is one device for the low or small environments from the 9300. Okay, so there is one series. So basically, if you are in the large organization or big organization, 9500 you're going to use in the spine, and 93 you're going to use in the leaf. Okay, but if you are in the small organization, there is one model which comes in the 9300 series, which is known as baby spine. Okay, so there is one model which you can use as a spine as well. Okay, so that is a low end switch for the spine device, because data centers are having a lot of routes and a lot of resources needed. So again, okay. Okay, guys, anyone having any question in this?
When you say the epic is connected, so is it logically connected or physically it has to be connected?
These are all physical connections, not logical.
But if it is more switches are there, every switch has to be connected to epic.
Sorry? Can you repeat?
If it is a more lead switches are there, so from every lead switch it has to be connected to epic. So that's what it means.
Again, guys, there is no hard requirement that every leaf you need to connect to the epic. Okay, right now I made only 4 leaves, but if I'm having 5th leaf as well, then I don't need to put it, right? I can connect it. So requirement is you need to connect your leaf with the spine, not with the epics.
Actually, what is the use of epic?
So epic is your controller, which is gonna do all the centralized thing for you. Okay, I'm gonna show you. It's gonna provide you the GUI. It's gonna provide you the configuration point. It's gonna provide you management point, monitoring point, everything.
Yeah, could you tell me, like you said, right? No STP, no blocked ports. Like, then how this spine and leaf are connectivity? Like, it will
So
work.
at the physical layer, you understand, right? Whatever the link I need, I gonna put it either via 40 gig or 100 gig or whatever it is, 10 gig, right?
Yeah.
So physical layer is okay, right? After that, L3 is gonna run between them, and there is a protocol which is known as integrated system to integrated system, in short ISIS, which is gonna run. Okay.
Okay.
So this is the protocol which is automatically enabled. You don't need to do any configuration. Once you plug your leaf to the spine, once there is a complete discovery process, which is going to happen, which we're going to talk about in next 10 minutes. So after that discovery process happens, then this protocol kicks in and it automatically builds your L3 adjacencies over the fabric. Okay. And then later on so this is in the underlay. After that, VXLAN will run over in the overlay. So again, we're going to talk about later on. Don't worry.
Thank you.
Yeah.
Yeah, in the
One,
underlay, can't we use apart from ISI's other protocol?
No, you cannot use any other protocol. This is the only protocol which is automatically enabled, and even not you. There is a very small little configuration which you can do in this, because things are automated. Automatically, it's gonna make the adjacencies. That only the timers and the very small things you can change over it.
Okay.
we are facing major disadvantage or issues with ACI related to CRC stomping. So basically, these switches are using cut through mechanism because of which if any leaf switch receiving any error frame, it just increments error, whether it's received from someone else or it is actually getting corrupted on the switch. And those stomp CRCs, it is circulating among all the leaves, and it's really hard to find out exactly if there is any issue genuinely or not. That's the.
But why are you getting the CRC error at the first place?
Actually, there are we are getting we suspect that we are getting the CRC injected from AWS, our AWS side, due to Broadcom issue towards the AWS side, but we are not able to prove because of the stomping feature.
Again, for CRC errors, basically that is going to happen because of the SFP things. If their SFP is corrupt or it is malfunctioning, then basically you will get these CRC errors. But anyways, if you are getting it from the AWS, and what Cisco is saying in for that?
So Cisco is saying Cisco captured the logs and they're saying it's a Broadcom issue, and it is getting injected from the other side. It's not that there. I mean, Nexus is creating or corrupting the packets frames. But we are not able to identify it properly. So we are doing ER span and stuff.
If that is a broadcast issue, then Broadcom issue, then they're not going to tell you that there is their issue. But I have managed a lot of data centers related to ACI. I never get this issue. It means CRC errors, we also getting it. Okay, but that is due to the SFP problem.
SFP, yeah.
Mainly.
Yeah, right, Pankaj. So even in our organization also, we face the same. So if you type the command show interface counter error, you will see like from where these errors are propagating. Then after that, you need to identify that spine it is propagating from leaves, which spine. Like that, you need to go and you need to change the module. So we fixed it after doing those. So
yeah, no, our challenge is a bit different. I don't want to eat up too much of time here, but our challenges are these errors are genuinely received CRCs already like storm packets, or it is getting corrupted on my SFP or on the port or on the switch. That's the issue, to identify the problem.
Yeah. So we're gonna discuss later on, Pankaj, no issue. Okay, so.
So I have a few questions, right? The epic connected to the leaf, is that will be a layer 2 connectivity?
So again, this is gonna be a management related connectivity. It doesn't matter. Basically, it is a layer 2 connectivity. You can say like that, but this is only for your control frames. Okay, data traffic will not go to your epic. Okay. So for example, if I am having one server which is connected to my leaf, okay, this is one server, this is another server. Your server traffic will not go over the epic, okay, that is go via leaf to spine and then from the spine to another leaf. So your epic will not come into the path, your controller will not come into the path, okay. So this is what, so it doesn't matter whether it is layer 2, layer 3, it is only for your control plane frames.
Okay, fine. And like you mentioned, like a baby spine. So I have come across one more terminology like super spine. So do we have that like spines connected to the spine or like?
Yes, that is also there, but yes, that is going to be advanced topology, which we're going to discuss later on in the course.
Okay, fine. Yeah, thanks.
Okay, so there is a question in the chat. As long as no STP and ISIS running in the background, that means fabric path is enabled. So no, Ali, fabric path is not enabled because here we are not using fabric path. Okay, by default we're gonna use the VXLAN, which is also gonna enabled by default. Okay, so between your leaves, your VXLAN is also gonna enable by default. Okay, but later on I'm gonna tell you about this VXLAN. Okay, so fabric path is not enabled by default, and even it is not enabled on your traditional Nexus devices as well. If you want to run fabric path, you need to enable it. Okay, there is no default mechanism of running the fabric path. Anyways, nowadays no one uses it. Okay, because it has disadvantages which is fulfilled via VXLAN. Okay. So, guys, why we use spine switches? Why we use spine switches?
What's the question again?
Why we use spine switches?
Centralized.
So spine is basically your backbone. Okay. They keep track of all the things. Okay. Now, if we talk about spine switches, mainly you will come across with the Nexus 9500 series switches. And there are three models, especially which is 9504, 9508, 9516. Okay. So difference is basically the slots or the line cards that you can fit. So here you can go with the 4 data line cards. Okay, slots. You will have 8 here, you will have 16 here. Okay. And if we talk about like 9508, so it is a complete 13 RU rack unit. So it is a very like a big, you can say, device. Just a second, let me disable the annotation. Okay. So basically all these switches is gonna support your 10 gig, 40 gig, 100 gig, 400 gig. Okay. They can run in both of your NSOS and ACI mode, but not at the same time. Okay, one time. Either you can run it in NSOS, either you can run it in ACI. Why this? Why they give this facility? Can anyone tell me?
So we can do our work in NX OS mode also as well as ACI modes also.
But why? What is the advantage you will get over it?
The flexibility to upgrade the existing infrastructure like NX OS to ACI.
Okay, but what is flexibility you get?
Just adding the licenses that they can upgrade the network from the NX OS to ACI mode, right?
So basically right now you will have the hardware refresh. Okay, but you are not ready for the application centric mode or application centric infrastructure, I can say, because guys, there is a lot of planning need to do before you moving on from the traditional environment to the ACI environment. So right now your architects are not ready or your teams are not ready, but your hardware refresh is there. Okay, so right now what you can do is you can buy these switches and run it into your traditional NXOS mode. Later on, when you are ready, you can get the license. Okay, and you can move on to the ACI mode. Okay, that's why this functionality is there.
Means by default it's in NX OS mode, right?
Yes, you can run it even if from the
Okay.
first day in the ACI mode as well.
And after that we got the iOS, so we can move into ACI.
Mm.
Okay. And that what mean by that 4, 8, 16? That means there are 4 Data card slot means 4 ports available for
Yes.
it. Fine.
So this is like a chassis where you are having the slots, right?
Okay.
So four slots are there. When in the bot, then after that you will have a supervisor engine slots. So supervisor engine like first slot, supervisor engine second slot. Okay, so 2 slots are there for supervision. After that you will have a power supply slots. So for example, your power supply 1, power supply 2, so power supply 3, 4. Okay, so like that way. So 4 and 9504 is gonna be having 4, 8 is gonna be having 8, and 16 is gonna be having 10 power supply.
So
Okay,
which
which
what is the soup? The soup does it have a model? Like
soup
you know
is soup is known as supervisor engine.
yeah, I'm just trying to ask if it has like model the types of models. You know, in the Nexus we have other
So
sort
there,
of
yes, so there are 2 models, soup A and soup B.
Okay.
Okay, soup A is gonna be our 4 core with 16 GB of RAM, and this is gonna be a 6 core with 24 GB of RAM.
Okay.
Okay, and if anyone is new to the networking, supervisor engines handles your control plane. Basically, it is a CPU, or you can say like handling a lot of control plane applications. Okay. Then you are having the fabric modules, which is at the back of your chassis. Okay, which is going to provide the capacity to forward the traffic from one line card to another. Okay. And you will have a system controller cards, which is also present in the chassis. So system controller cards is gonna be take care of your temperature, power, etc. Okay, so this is what you will have different components in your spine. Okay. Now after that, let's come to the leaves. So our leaves is why we use leaves, guys.
For connecting end user.
Your access layer.
To connect to the end host.
Okay, so basically it is going to be a connection point, right, for everything. Right now, let's assume it is for everything. Later on, we are having some topologies where some things you can connect it with your spine as well. So right now, let's assume, like for example, if this is your spine layer and this is your leaf layer. Okay, so this is gonna be complete ACI fabric. And if you are having your 3-tier architecture, which is running in your traditional environment, so your core layer, distribution layer, access layer. Okay, so if you want to connect your core device, you're gonna connect it to the leaf. Okay. Similar way, Epic is also gonna connect to your leaf. Okay, if you are having your WAN router, that is also gonna connect to your leaf. Okay, if you are having switch, so this, let's assume this is switch, it is also. If you are having firewall, this is also gonna connect to the leaf. Okay, so all the things is gonna be connected to the leaf. Again, we are having some designs where spines, where things are going to connect to spines. We're going to talk about those designs later on. Okay. Also, your host or end users, okay, your servers, everything. So basically, it's going to learn your MAC addresses, IP addresses, everything. Okay, and then VXLAN is going to run from leaf to leaf. So which is going to encapsulate your traffic. And here, guys, this VXLAN is also automatically enabled. You don't need to do a single command. Okay, you don't need to run a single command to run it. So again, we are having a completely one class on VXLAN, which we're going to discuss about it. Okay, so basically Neve uses your Nexus 9300 models. Okay, again, these are your switches. Okay. So if we talk about generations. You will have Zen 1, Zen 2, Zen 3. The difference in those is gonna be, first difference is gonna be, it is in the chip. Okay, the switch on chip, or you can say SoC, which is associated, again, this is a very technical thing which I'm telling you. Let's see, some of the people I don't think able to understand. So NFV plus ALE. Okay, so this is gonna be your ASIC. Okay, so it is gonna be used. So this is what Broadcom on Cisco is making it when they are having first gen leaves. After that, they commit with its, Cisco commits with own ASIC. So they're not gonna use the Broadcom chip. Okay, so that is gonna be LSC, which is their own ASIC. They're gonna use it, and then also in the Gen 3, they're gonna use their own ASICs. Okay, so these are the normal devices with no nomenclature. In Zen 2, normally you will see the nomenclature after the model. You will get EX and FX. Okay, these are the names you will get it. I'm gonna discuss later on what is EX and FX. Then in the Zen 3, this is gonna be FX2 GX, like that. Okay.
So, just a small question. Isn't it FX2 qualified as a Gen 4, or it comes under Gen 3 only?
Although if you see it in the documentation, there is no name of Zen 3 as well. Okay, but let's assume it to be part of Zen 3.
Okay. Okay. Thanks.
Okay, so again, after that, the advantages between them is gonna be, with each generation, you will have large buffer. Okay, which gonna holds your configuration, holds your this all the MAC entries and all that stuff. Okay, so you have large internal buffer, like in Gen 1 you are having 16 MB buffers, Gen 2 having 40 MB buffers. You will have large tables. Okay, like in your EX and FX, you can go up to 256,000 MAC addresses. Okay, then you will have the telemetry features which is present in the Zen 2.
Actually, this Gen 1 Gen 1 is actually a chip level, or the software?
Sorry?
Is
Gen
that
1
separate
is
device? Gen 1,
separate
Gen 2,
device,
Gen
or is the hardware internal?
Yeah.
What
So
actually?
this is what I'm telling you, the internal architecture. Again, the models is going to be from the 9300 series switches.
Okay, that means it's built-in lips switch you're talking about.
Yes. So if we talk about the first gen, for example, let me tell you the model numbers. Okay, so 9372PX, then 9396TX, 93120TX, like that. Okay, so these are supported like that. Now the second gen is going to be having the model number of 93180 YCEX. Okay, 93108 TCFX. Again, these YCs, these are the letters which is going to represent the port capacity and all that stuff. Like which module they're going to support, which bandwidth they're going to support, like that. Okay, and then you will have the third generation, which is going to be 9336C FX2, like that. Okay, there are other models as well.
Okay, and what is meant by that BCom plus Cisco? What is that?
So BCom is Broadcom. So Broadcom is giving this chip NFE, and Cisco is making ALE. Okay, this is internal parts of your ASIC.
Okay.
Okay, guys.
Can you
So
just send me the last latest model is 93336. Okay.
yeah, so again, this is 1 year back. I need to check the current model also. Okay. So if you want to check the current models, you can directly check the 9300 data sheet. Okay. Right now I'm not removing this screen.
नहीं मैं तो खा लिया पेट
Otherwise,
भर गया तो रात के लिए कटोरी सूखा ही है मतलब तो क्या रख दो कटोरी में फेंक नहीं फेंको मत रख दो एक कटोरी में
Subodh, can you put your mic
तो
on
बाकी
mute?
सब बर्तन क्लियर कर दो ना
Thank you.
FX means it's a fiber port, right?
No, so F is not means fiber port. This is gonna be having different nomenclature. Okay, so this YC, TC, PX, TX, these is gonna represent the things. EX means enhanced. Okay, so E means enhanced. Okay, which means it is better device than your first gen. and your FX and all those FX2 is also going to be better than your second gen. Okay, so it's going to be better in case of your buffers, internal memories, then deeper telemetry, all those stuff. Okay, which again, right now I'm not going to discuss those features. We're going to later on discuss those things. So if you want to talk about the fiber, okay, so this is what it represents. So PX represents 1 or 10 gig SFP plus port. Okay, your TX is going to be 10 MB or 1 gig or 10 gig, but it is the copper. Okay, Y is going to use for 10 or 25 gig SFP plus. Y is the 25th letter, okay, of alphabet. That's why mostly it is used with the 25 gig ports. Okay, then if wherever you find the Q letter, that represents your 40 gig SFP plus, or basically QSFP plus. Okay, C represents for 40 or 100 gig. Okay, which is QSFP28, or it is also known as CPAC, or one more name is there. Okay, and there is one more letter which is L, which is going to be for 40, 50 gig. But again, guys, Cisco is not consistent with these letters. So again, you need to check it with the data sheets about these. Okay. So after this, let's quickly talk about the Epic. So Epic is the full form of Epic is Application Policy Infrastructure Controller. So basically, I told you this is going to be UCSC softwares, okay, which is having the Epic software installed on them. They're going to be in your management plane. Okay. So not even the control plane. Control plane is going to be handled by a spine. So they're going to be management plane. So no control plane, no data plane. Sorry about that. I previously said that it is in the control plane. So it is not going to be in the control plane. Okay, then you will have a single point of configuration through AR Epic, which you can do. Okay. Then health monitoring, you can check it through that. It's gonna stores your all configuration. Okay. So ACI related configuration means is whatever the configuration you are doing in the ACI fabric. Okay, it is gonna be connect to your leaves, and this is gonna be in the active state, active cluster. So means you can log into any of the Epic to do the configuration. So whatever configuration you're going to do with one Epic, it's going to be replicated to the another Epic automatically. Okay.
This active cluster means?
Active means you can, like, all of them is going to be active at the same time. So you can log into any of your Epic and you can do the configuration. Okay, it is not in the active standby state. Okay.
So we can make all the configuration changes from Epic only, right?
Yes. It is in the management plane, so you can do all the configuration changes through Epic itself.
So we can do any changes on any Epic. Is it right?
We do all the changes from Epic. Okay.
I'm asking if suppose we add a VLAN 10 on Epic 1, okay.
So not on Epic, basically whatever you're doing it from Epic, that is going to be for your leaf and spine. So configuration goes to your leaf and spine, but this is the management part, from where you're going to do it. Okay. Tomorrow I'm going to show you with the demo, like exactly how it's going to do it. Okay, so you will have.
We can, that means we can do any changes from any Epic, right?
Yes, you can do it from any Epic, whatever you want. So if we talk about the hardware, you will have, so again, it is a C series server, but it is into two different gens. Not actually generation, it is actually depend on your environment. Okay, so this is, if you talk about medium, this is going to be C220 model or 240 model, which is M3, M4, M5. Okay, so M3 is Gen 1, Gen 2, Gen 3. Okay, and if we talk about large, means it is having large buffers and all that stuff. Okay, so C220, 240, L3, L4, L5. Okay, so it is again Gen 1, Gen 2, Gen 3. So these are some of the models which is comes in the Epic. But now the interesting thing that you need to understand is how many Epic you want to put it into your cluster. Okay, so minimum Cisco represents says 3. Why it says 3? Again, I'm gonna tell you that. But up to how many leaves your 3 epics can handle. Okay, so there is a limit. Okay, so as per Cisco, up to 80 leaves, if you are having it, you can go with 3 epics. Okay, but if you increase it from 80 leaves, then up to 300 leaves, you need to install 5 epic. And then if you go above 300 limit, then you need to go with the 7 epics. Okay, and this limit will go further as well. Okay, right now this is still here, but the plan is still the 31 epics.
This 3 epic 80 leaf, this includes only the leaf or the spine devices also?
No, only the leaf. You need to do it because spine is always the less. I have seen around 8 or 10 spine maximum.
Okay, fine.
You know, the apex, do they all do the same role or do they have individual roles they do?
Sorry?
The apex, do they have the same role? Do they do the same role? A bit like, you know, on Cisco Sg-1, once we manage vSmart, vBond, is this similar in ACI?
No, that is different. That is here, it is different.
No, but all of them, are they going to do the same role? It's just redundant between them, or do different one of them do different roles within the apex?
I'm not getting you. Different what?
No, do you got 3 apex which Cisco recommends? Do they do different functions? So do they all
No, no. They're gonna do the same role.
All right.
Here you are having only one controller which is in the management plane. When we are talking about SD-WAN, so you are having 3 different controllers: vManage, vBond, and vSmart. So there are different roles. Okay, this is for your orchestration plane or security plane. This is for your control plane, and this is for your management plane. Okay, but here the things is not like that. Epic is only for your management plane. Your control plane is going to be handled via spine. Okay, and leaves separately. So data plane, control plane is going to be directly handled via leaves and spines. Your management plane is going to be supported via Epic.
So in terms of having 3, so on that first one where it says you can support up to 80 leaves and you need 3 apex as a minimum. So when you log on to apex, when it pushes out the config, is it individually distributed? So one apex will push out to a certain amount, or is it just each apex will push out?
So what is going to happen is whether you gonna connect your apex to any of the leaves, definitely your apex is going to be connected to leaves. So by default, your configuration is going to go to your other epic automatically. Whatever that you're going to push it out. So they're going to sync it with each other through the leaves. Okay.
So I have one question. If you are talking about L3 or any M3 devices, so they support the maximum port also, right? Maximum number of ports. Will it different between the 80 leaf? It depends on the leaf or what?
So here, if you talk about L3 devices, there is a concept of L3 out. Okay,
Right.
so L3 out is having a different scalability guide or port count. Okay, which is different from this. So this has to be done. This has to be used with the topology itself. Okay, like how many leaves your epics is gonna support 3 epics. Forgot about L3 ports as of now. That is different from these.
Okay. Yeah, that was my confusion. It's not related to the ports. It is related to
No.
number of leaves. Right?
Yeah, so these are gonna be related to your devices, your switches.
Okay. 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 Got your point. Thanks.
So spine handle control planes, okay, epic handle management, and it's leaf handle data plane.
So spine is gonna handle your leaf and spine, both is gonna handle control and data plane.
Okay, okay.
And management plane is gonna be handled via epic.
Okay, okay.
And leaf and spines are not controllers. Okay, your epic is the only controller here.
Yeah.
The number of spine, how much
I
do
have
they require? Depend on number of spine.
Sorry?
How the scalability of the spine? How much, for example, 30 leaves? How many spines will
Yes,
be
so
there?
that is also there. I need to check that limit. Right now, I don't have it remember in my head. So there, every spine is gonna support the leaves as well, right? So there is a limit. Okay, and we need to check that document.
Okay, fine.
Okay. One small question. I might have missed that particular thing. Why we do not connect epic to spine?
So again, there is a hardware requirement which we need to use it. Okay, so there is a limit. You don't need to connect anything to spine. Only when they come up with this solution, everything is gonna connect it to the leaf only. But now, as we are in the ACI 4.0, now there are some situations where some of the devices you can connect it with the spine. But again, right now, Epic, you cannot connect it with the spine. Okay, you can only connect it with the leaves.
Okay. Okay.
Okay, guys. So we're gonna stop it here today, and tomorrow we're gonna continue. I'm gonna show you the graphical user interface tomorrow. Okay, and I'm gonna discuss more about the epics and all that stuff. Okay, tomorrow is gonna be a last class for the free access. After that, next week is gonna be logged class. So now we are still having 5 minutes. If you are having any question related to the batch, so you can ask me.
Yeah, with regards to the course, you will be providing like workbook, all those things. Can you just explain
Yes.
regarding the labs and all?
Yes, so we're gonna provide you the workbook. Let me just show you the workbook. Just a second. Support at the rate network.
Means you will provide all the things like recording and workbooks and lab access.
So basically, I'm not gonna provide you anything because I'm gonna just teach you. Okay, but our backend team is gonna provide you the things. So portal, you will get the portal access. Okay, let me tell you the things. You will get the portal access. Okay, on the portal, you will get. So every lecture is gonna be recorded. Okay, it will be placed on the portal, and then you can watch it from that in case you missed it. Okay. Related to workbooks, we're gonna upload the workbook again on the portal. You can get it from there. We're gonna provide you the lab access. Okay, for the virtual environment, you can access the lab any point of time till the course end. Okay, it is gonna be 24/7 access till the course end. After that, we're gonna stop the access. Okay, so you need to finish the lab with the course time. Previously, we give the extra time, but people will not do it because of that extra time. So this time we are come up with the course itself. Okay, and so workbook we're gonna share. What else? I'm not gonna use the slides, guys. This is how I teach it today. This is how exactly I teach. So again, if you want, you can take the screenshot of these from the recordings. Okay, you can take the screenshot yourself. What else? Tell me. So workbook, let me show you. Meanwhile, any other question, guys?
Do we cover topics for like OTV, ISAS, VXLAN? Like, because earlier I have seen SDN organization had the Nexus part also. So now I'm not seeing that.
Yes. So right now we're not covering the OTV. Okay, VXLAN we're gonna cover it, but only the basic of it, whatever you needed for the this one for your ACI batch. So VXLAN over the Nexus NXOS, we're not gonna cover. VXLAN over the ACI we're gonna cover.
Is L3 out is a mandatory for any L3 device? Is it a mandatory to create this L3 out?
Sorry, not getting you.
L3 out.
L3 out. Okay, so
Yeah,
L3 out is needed when you need to do the communication, L3 communication with the external world. Means external world here is when you are communicating from your ACI to the traditional network or any WAN router or any other device. Then you need the L3 out.
And the L2 out?
L2 out when you doing it with the external L2 network, means L2 switch or the switch level communication.
Okay, connections from spine to leaf, is it direct back to back or through a switch?
So it is directly connected back to back. Your spine to leaf connection is gonna be directly connected.
It's a lot of leaves, yeah. So how can we connect them if it's a lot of leaves?
So from the leaf front port to the spine front port directly. Through the patch panel you can do it, okay, but it should be a direct connection without any other device in between.
Yeah, if spine is not enough because we have like 100, for example, 100 leaf.
So you need to have multiple spine then, or you will have you need to add the line cards. So if you are having 9516, you can go with the 16 line cards. Every line card is depend again how many ports you are taking in the line card, right?
So it cannot be through a switch or through something. It has to be back to back, right?
Yes, it has to be back to back, not through the switch.
Okay, MPBGP is not used in ACA.
So MPBGP is used when we do the L3 out, otherwise not needed. Okay guys, so there are total 10 versions of workbook. Right now I just copied to this desktop only 2 versions. Let me show you. Okay, so there is a complete step-by-step workbook. Okay, so this is for the first part, like how you're gonna configure the APIC. First of all, very basic, from starting from scratch. Okay, this is how you're gonna configure it. After that, how you're gonna get the GUI access of your APIC. Then how you're gonna add the leaves and spine to your APIC. Okay, so this is our first lab.
When is it going to start? What is the timeline?
So we already started from today. Okay, the lab is going to be from the next week because I need to tell you the theory before doing the lab. If you don't know what is leave, what is spine, how are we going to do the lab, right?
Yeah, I just wanted to know the timeline.
Yes. So yes. So we already started from today. Okay, this is not a demo class. This is the live course class I am taking. A lot of the people's already enrolled in this course.
Okay, got it.
Yep. Okay, so this is lab 1, this is lab 2. Similar way, we are having around 9 labs. Okay, 9 labs total, 9 or 10. So this is again how to create the policies and all that stuff. Okay, multiple policies.
Topics like multi-site, multi-pod, like those are covered in the lab or like on the concepts. How?
So they are as a part of DC ACI. If you see the blueprint of Cisco, they are only the theoretical topics. So we're gonna cover it in the theory part only.
Okay.
Related to multi-site, multi-pod.
Do we cover help us with the CLI commands like on the leaf or ACI like
So
also
again,
there
a lot of the CLI commands will not even work. Okay, on the virtual platform. Even on the if you talk about the real devices, a lot of commands they depreciated, because again with this, what they want is either you go with the GUI path or you will go with the API path. Okay, which is to do with the help of programming. So again, a lot of CLI sub commands are not even supported. But again, I will try to show you some of the basic commands, but here we are having limitations.
Okay.
Okay, what else, guys? So this is the link in the WhatsApp in the chat. There is a WhatsApp numbers. Okay, and there is an email over which you can contact to get the course fee. This is a dual course, which is first gonna cover the ACI. DC ACI is the exam which we're gonna cover it up, means the slave and the course. Okay, and then the next one is gonna be SD-WAN. So ENSD WI is gonna be the name. Okay.
I'm having one last question. It might be a
Yes.
silly question. What will be the fees of this class?
So this is what you're gonna get it from the backend team. Okay. Even I don't know about the fees. Okay. So these numbers are there. You can directly do the chat.
For ACI, like total, how many class will be provided?
Yes. So it is gonna be 1 to 1.5 month course. Weekend, 1 hour, 1.5 hour to 2 hours class.
And if you want any daily class for 1 or 2 hours, so
So
it will
right
be
now we are not running a daily batch. Okay. Right now it is a weekend batch only. Maybe in future we're gonna do it daily. Okay, guys. Any other question?
You cannot run a home lab setup on this, like is not possible.
So again, we not supported the home lab for this ACI batch. Okay, but you can try to Google, and if you're able to find the things, you can do it yourself. We're not gonna provide you any software and like licensing things.
It requires 64 GB if you want to run home lab.
Okay, guys. Any other question before we wrap up?
I'm good. Thank you for
Okay.
this session.
Okay.
It was
Yeah.
very
Thank you,
informative.
everyone. Yeah.
Hello, Shank. How are you?
Yes. Yeah. Hi, Gul. How are you, man?
Yeah, I'm still waiting.
For which? SD-WAN?
Yes.
Okay. So after this, we're gonna start with the SD-WAN, or else in the weekdays, we're gonna start the SD-WAN if you want to join.
Yes, definitely. Please let me
Okay.
know, okay, on Slack.
Yes, sure. You will get the mail.
Thank you, man.
Okay. So guys,
Mr.
tomorrow
Shan.
also there is a class. Okay, so tomorrow also you can join. Those who not enrolled. After that, we're gonna close this one. Yeah, hi Togba.
How are you, Mr. Shan?
Yeah, I'm good.
Yeah, I'll send you a couple of messages on Slack, but I know you're busy, so.
Okay. We're gonna discuss it on later on directly.
Okay, all right.
I have
Thank you.
seen it, but I forgot to reply you. I'm gonna reply it. Okay, no issues.
All right, that's fine.
Okay. Okay, guys. So thanks a lot for joining today. Tomorrow we're gonna meet it again on the same time. Thank you. Have a good day. Bye.
Thank you.
Thank you.
Thank you.